Alright, so for our ME3901 project, we built a coil projectile launcher controlled by a motor to rotate to various positions. So first we're going to talk a little bit about the coil mechanisms, and right here this is the base before we assembled it, so we can see all of our components. And here we have one Arduino that's controlling the firing mechanism, and we have two relays. So the first relay, which is this relay, controls the charging from a power supply, which is this red and black wire, and they're going to charge this capacitor when this relay is opened, and then, or no, when this relay is closed, and then it will be opened to isolate the power supply from the capacitor, and then this board controls the activation of these two MOSFETs in parallel, which allows the capacitor to discharge into the coil, which is going to be attached right here. And the Arduino here precisely controls the amount of time that the coils are allowed to receive current for, and it's about 50 milliseconds is what we found to work the best. And then after that, they're going to close. They're going to shut those transistors down, or those MOSFET, transistor, same thing. And then as soon as that happens, we have these flyback diodes. So the current in the inductor, you can't, or the coil is an inductor, and the current cannot change instantaneously. So these diodes provide a flyback path for that to go to prevent a voltage spike. And then this second relay is activated, and that controls a discharge circuit across this resistor up in the top. And that's going to be, this relay is going to be closed for 60 seconds to allow the capacitor to discharge.
All right, so to fit all of our electrical components into this, we had to create a housing. For this, we chose to do it in SolidWorks and 3D print out our models. So the idea here is we have this base plate down here, which contains most of our electrical components. Some of it is outside due to the size restrictions of our print bed. But so inside here, you just saw all the relays, the motor, the breadboards. And so all of those wires are controlling our circuit. And so then as we go up, we have our actual turret system. And so it's built in a modular system so that you can easily manage the wires throughout it. And in the middle, we have our tube with our coil wrapped around it. And in this housing right here is our second motor, which controls this movement for our ultrasonic sensor that detects any objects. And each of these are just connected through a series of pins, just right on the corners of each of them.
All right, so as you can see here, we have our full system just about taken apart. We did have a base plate for it, but due to, well, as you can see how complicated all the wiring is, and it was causing a lot of friction, a lot of parts were getting pulled that we didn't want to get pulled. So for demonstration purposes, we are going to take the base plate off so you can see how everything works. So as you can see here, we also have two Arduinos. We have the Arduino as mentioned before that controlled the coil mechanism for firing with the capacitors, the secondary circuit, but we also have a second Arduino with two H-bridge motor controllers, which are responsible for controlling the turret mounted stepper motor as well as the ultrasonic radar stepper motor. Now, moving up towards the barrel, you see this custom-made optocoupler, which uses a phototransistor and an LED. And how this works is that this is constantly emitting basically a laser, and that these are constantly in contact with each other. And the second the bullet comes into contact and cuts the signal, this will return a low signal, which tells the code that, hey, the bullet's been fired. Let's start the system all over again. And then up here is our ultrasonic sensor, which will rotate 180 degrees clockwise and counterclockwise, which will basically, once it detects an object, tell the turret stepper motor to rotate the same number of steps that this is currently rotated from a common 0 axis. Now that we know the system works, we also have the power supply. So here we have a power supply that operates on 2 volts, which is responsible for operating the H bridges. And we also have a 25 volt power supply, which is responsible for charging the capacitor. Ideally, we would have had it to 50 volts, but due to the limitations of all our components and our safety, we have it at 25. And we also, here you can see the bullet, which is a nice screw, which is kindly donated from the lab floor. I will now place it inside the device, lock it in with a nice cap. And now that everything's turned on, if we give it some nice power, it'll then rotate clockwise, rotate counterclockwise, and now if I put my hand in front of it, rotate to that position, make sure it's in line. Now, as you can see here, we now have a button which will now be pressed. This is now charging the capacitor. Capacitor charges for around 5 seconds. Once it is charged, we have the fire mechanism, and look at that. Projectile came out flying.
And now we can see that the other relay is on, and that is discharging the capacitor across this resistor here, and that's going to happen for 60 seconds just to make sure it's fully discharged.
Really memorable. The days that I saw you in a lab, which was maybe one, was really memorable for me. And you told me that